Okay, problem number 1 asks you to write a scientific notation number in standard form. So part A, we look at the exponent. If the exponent is positive, it tells me it's going to be a big number. Okay? The second one, the exponent is negative. When the exponent is negative, it means we're going to have a little number. Okay, so remember that when you get your answer. Now, the exponent tells you how many places to move the decimal. So I'm going to move it 2 places. If I moved it 2 places to the left, it would become a tiny number. And I want a big number, so I'm going to move it 2 places to the right. Now notice I started the decimal, and then I don't count 1 until I go to the next one. There's 1, and there's 2. So my decimal now is here. So my number is 902. For my second one, it's going to be a little number. If I move to the right, I would create a big number. It'd be 866. So instead, I'm going to move to the left. So I start here. I'm going to start at the decimal, but I don't count until I go to the next space. 1, 2, and then I draw a decimal. This means I have to fill in the wave with a 0. And so my new number is 0.0866. Now, you can also just use your calculator and put those 2 numbers in, and it will give it to you in standard form. So let's try that. So let me demonstrate this. Okay, so I'll just come in here into my calculator, and I'll just type in the number. And when I hit enter, it gives me the number in standard form. So that was easy. Okay. So you can use your calculator to help you if you're having problems or if you want to check your answer. Problem number 2 gives us a graph, and it asks us to graph this function. So since it's a linear equation, we know that if my equation is negative 2x plus 5 is equal to y, the number in front of the x is the slope, and the constant is by itself is my y-intercept. My y-intercept is on the y-axis always. So I can go ahead and draw that dot. Okay. And then from this dot, I can use my slope to find a second point. And my slope is always a fraction, so I can put it over 1. My top number tells me how to go up or down. So since it's 2, I'm going to go down 2. And then my bottom number tells me how to go right or left. And since it's positive, I'm going to go to the right 1. So from the y-intercept, I'm going to go down 2 and then right 1. And then I can connect these 2 and I've got a line. Okay? That's one way. A second way you can do this is you can use your calculator and you can put in negative. And notice when I put in the negative, I'm going to use this bottom button there. Negative 2x plus 5. Now, I can graph it and I can see it, but I can't graph it on my paper with the picture. Instead, I need some points. So I'll say second graph, and that gives me the table. And there I have some ordered pairs now. So I could use 0, 5 was one I saw. Put another one up there. I could use 1, 3. I could use 2, 1. So you can see I'm getting these from my calculator. So these are ordered pairs, and I could just choose any 2 and I can graph from there. Parts B and C ask for the domain and the range. Now for a line, we know that really it goes in both directions, left and right. So the farthest left it would go would be negative infinity, and the farthest right it would go would be positive infinity. This would be my domain. And then for my range, the lowest it will go is negative infinity, and the highest it will go will be positive infinity. So for a linear equation, your domain and your range are always negative infinity to positive infinity. The next problem asks us to square the binomial. This is the gotcha question I've warned you about in class. Make sure you write it out, and then you'll make sure you get it right. Because what people do is they forget that you have a middle term here. This is c squared plus 9c plus 9c plus 81. which is c squared plus 18c plus 81. Sometimes people want to say this is c squared plus 81, but you can see clearly if you expanded it out, you would realize that there is an 18c. Okay, so don't try to apply the product to a power rule. This is not a product. These are two. It's an addition. It's a binomial. So just write it out twice. That's what it means. C plus 9 squared, and then you'll definitely get this problem right. Okay, so the next problem asks if these four graphs are functions. I just clipped two of them to go over with you. We're going to use the vertical line test, and I wrote it here, so if you want to reread it. It says you take a ruler or a straight edge, and you draw a line vertically. And if the vertical line you draw intersects a graph more than once, it is not a function. So what that means is we just draw a straight line vertically, up and down. Okay? And if you notice, it intersects a function or the relation at two places, right there and right there. Okay? So that means it is not a function. It can only intersect at one place. Okay, let's try this one over here. So if I draw a line here, well, that intersects at one place. Let me draw another place. How about a vertical line here? One place. One place. So this is, yes, it is a function. So no matter where you draw a vertical line on this graph, that it only intersects one place at a time. Okay, so that's the vertical line test. Okay, our next problem gives us a graph. It's a parabola, right? We know quadratic, oops, and it says find f at 0. So f at 0, we know that function notation tells us that whatever's in the parentheses is my input, or in other words, your x. So they're saying, what is the number that would be filled in if you had a point on the graph? If 0 is your x, what is the y? So let's just see what that would be. So if I go to 0, well, I know if my x is 0, that means I'm going to be on the y-axis. So I would go down to here. So f at 0 is 8. Next, they ask you f at 1. So this means my x is 1. So they're saying, what is the y coordinate when x is the input? So if I put in a 1, that would mean I'd have to go down to be on the graph, and I'd be here. That looks like a negative 12. And then it says f at 3. Remember, this is always the input, always x. So if I go over to 3, I'd have to go down, and that also is negative 8. Oh, I'm sorry, did I say positive 8? Let's make that be, sorry, a negative 8. So I just corrected this. I'm sorry, I didn't pay attention there. So, and then it says, find the values for x when f of x is equal to 0. So f of x is equal to 0. So this is my input, and f of x is my output. And another, we usually use y for output. So they're saying, this time we're doing the opposite. What is x when y is 0? Okay, so I know that when y is 0, it's going to be on my x-axis. Every coordinate on here has a y equal to 0. So I'm going to have two places where my y is 0, where I intersect my graph. So that looks like it's negative 1 and 4. Okay. Now, part E says, find the x-intercept. Well, you can see I have 2 in this case, and write them as ordered pairs. So it's going to be negative 1, 0, and 4, 0. Notice that your x-intercept, your y is always 0. Okay? And when we're looking at parabolas, we know that we can either have one x-intercept, where it just touches the x-axis, or maybe we have 2, like we have here, where at 2 places it crosses. But you might also have one that never crosses, and then we'd have 0 x-intercepts, right? Okay, the next question says, find the y-intercepts. Well, for a parabola, we're only going to have one y-intercept always, and it's always going to be where it crosses the y-axis. So this will be my y-intercept. And my y-intercept always has an x equal to 0. So notice my x-intercepts have a y equal to 0, and my y-intercepts have an x equal to 0. Okay? Now, the next two questions ask for the domain and the range. Now, they don't really show, and they do say in the directions here that you have to assume that this graph goes on and on. In other words, there's not an arrow here, but we have to know that it really does go on and on both directions. All right? So what's as far left as we go? Well, this left would be negative infinity to positive infinity. That'd be the farthest left to the farthest right. And my lowest to my highest, so what's the lowest my graph goes? My graph looks like the lowest it goes is 12.2. So negative 12.2, that's the lowest, I'm guessing. And it's including that, so make sure you put a bracket on that end where the vertex is. And then the highest will be infinity for mine. Okay? So it's always lowest to highest. And wherever the vertex is will be your lowest or your highest, depending on which direction it goes. And you will want to use a bracket. So just to make sure you understand, so if you had a parabola that went the other way, right? Well, let's assume that the vertex is at 3 there. So in this case, my domain is always still negative infinity to positive infinity. It will always be that for a parabola. And then for my range, my lowest in this case is negative infinity, and my highest is 3. And I want to make sure I put up a bracket. So this is just another example of checking the domain and range.